Okay, welcome back, everybody. In today's lesson, we're going to talk about percentiles and how to calculate percentiles when you have grouped frequency distributions. So we're going to learn how to calculate a percentile rank and a percentile point, which are two different formulas. And then obviously there's a homework assignment that goes with this exercise, which you can follow along with. So the first thing we're gonna do is define percentile and percentile rank. Now you may remember from the previous lecture, a percentile is a given score at or below whatever percent of cases lie. Now, percentile rank, that is important to know because that is related to a reference group. So if you were in the 85th percentile, that would mean that you were, or your score was equal to or greater than 85% of the cases. That would also obviously mean that there are 15% of the class who might have done better than you. So that's what percentile rank is. So percentile and percentile rank are very similar. The only difference is percentile rank, you have a reference group. Now, it's important to be careful about how we interpret percentile and percentile ranks. Knowing the reference group is absolutely essential. So let's say a person was in the 90th percentile. That sounds really good, doesn't it? However, if they were a college senior and they were the 90th percentile relative to high school seniors, that would be far less impressive, wouldn't it be? Because they have 4 years of additional education, so we would expect them to score very high. Whereas if we were to flip it around and we were to say that we had a high school freshman who was in a 12th percentile, in general, that sounds bad, but if I were to say relative to college seniors, now we're looking at them and saying, oh, not bad, because high school freshman relative to college senior, there's 8 more years of schooling. So long story short is that when we talk about percentile ranks, it's very, very important to know who the reference group is, because the number in of itself may or may not be as impressive otherwise. So you may recall this Morehouse and Sanders data from the previous lecture, and we talked about calculating frequencies and cumulative frequencies from the table, right? So in a grouped frequency distribution, we said that one of the challenges is that we don't know the exact score unless we do a stem and leaf diagram. But suppose we wanted to figure out what the percentile rank would be for an individual who scored a 109 on the Morehouse and Sanders test. Well, we have a series of procedures which would help us get there. Now, I'm going to show the process on a whiteboard, and then I'm going to come back to the slides sort of as a fact checking. All right, so let me stop this share, and I'm going to move over to the whiteboard. Okay, so what you can see here is that I've just transferred the data set onto the whiteboard. And what I've done was I wrote all the steps that we need to go through in order to figure out how to do this. So the score in question was 109, right? So we want to know what the percentile rank is for 109. Great. So the first thing I'm going to do in step 1 is identify my class interval. And I've intentionally changed the marker. Actually, maybe I'm going to do this in red because it might look better as a contrast. But so the first thing I'm going to do is, well, what class interval does the score 109 fall into? And I'm going to box that. So here I am boxing my class interval. Can you see what I've done here? The score 109 falls into the range of 100 to 109. So I'm going to write, okay, my class interval is 100 to 109. So that's step one. Now, step two, I have to determine how many scores are above that class interval, which is symbolic of H. How many scores are within that class interval, symbolic of I, and how many scores are below or lower than that class interval. Now, what I'm going to do is I'm going to identify it as follows. So the number of cases above my class interval in 110 to 119, there are 30 cases. And then 120 to 129, there's one case. So if we were to add that up, there's 31 cases, right? So I'm going to do 31 divided by the total number of participants. Now, if you add up the frequencies, just like in lecture 2, we had 153 participants. It matches the cumulative frequency at the top. So we're going to do 31 divided by 153. Okay. Now, the number of cases within that class interval is in the box, right? So that's 27, right? So we do 27 out of 153. And then the total number of cases below, we can cheat. We can add all these up, or we could look at the cumulative frequency below, and that would tell us our number. And that should be 95 out of 153. All right, so that's the first thing. Now, if you want to make sure that your sample is appropriate and you didn't mess up, you could also add all up your numbers. So 1 plus 7 is 8, plus 5 is 3. Carry the 1. 1 plus 3 is 4, plus 2 is 6, plus 9 is 153. All right, so we have 153 out of 153. Okay, so far so good. The next thing we're going to need to do is calculate these percentages. Now, you may remember the calculation for percentages, F divided by N times 100. So I'm going to get my calculator and I'm going to figure that out. Give me 1 second. Okay, so here we are. And now we have to figure out what the percentage of 31 divided by 153 is. So we do 31 divided by 153 times 100. Now we do times 100 in order to get a whole number, right? Or a whole percentage. So when I do that, I get a number that looks like this, 20.261. And I'm going to use 2 decimals for the sake of this demo. So I'm going to say this is 20.26. So the second number we had was 27 divided by 153. So we do 27 divided by 153 and multiply that by 100 to get a percentage. And here I get 17.647, which I'm going to round to 17.65. So 17.65 Our final one, and this is going to be important because of the formula to calculate percentile rank, which is below. Our final number is 95 divided by 153 times 100. And that's going to give us 62.09. All right. So here we are, 62.09. Now, we say percent. If I add up the whole percent column, I should get 100%, shouldn't I? So when we do this, we want to make sure we've now have no mathematical errors, because if you have a mathematical error and then you plug it into a formula, you're going to have a mistake. All right. So what I'm going to do now is I'm going to add these three numbers up and see what I get, to see if my numbers are so far so good. So I have 20.26 plus 17.65 plus 62.09. When I add that all up, I get 100 or 100%. Well, that's good. Now, I will tell you, in some cases, you might get rounding errors. So you might get 99.99 or 100.01. But if that happens, don't panic. That's a rounding error, and that does happen from time to time. So now I've done Hill. Step 2 is calculate the percentage of cases that are higher or below my class interval, I within my class interval, and L, which is lower than or below my class interval. Now I need to find the lower real limit. Now I'm going to define this because it's pretty crucial. Your lower real limit is 0.5 below the smallest number in the class. So my class interval was 100 to 109. What's the smallest number in that range of scores? 100, right? So to get lower real limit, I take that 100 and I minus 0.5, which is going to give me 99.5. So in general, the lower real limit is 0.5 below whatever your class interval is. So now I have everything I need to plug into the formula. L percent, well, L percent was 62.09. No problem, 62.09 plus the score. What was the score I was trying to calculate the percentile rank for? The question was, what is the percentile rank for a score of 109? So the score of interest is 109. 109 minus the lower real limit, which I've calculated to be 99.5, divided by the height. Now you may remember the height was the width of scores. So when we look at the number of scores between 100 to 109, what would the height be? Well, we take the highest score minus the lowest score and we add 1 to it, because remember the rule was the lowest number in that range is still part of that class interval. So 109 minus 100 gives me 9, plus 1 gives me 10, which gives me my height of 10. And then we multiply that by I percent, which was 17.65. Okay, 17.65. And now my formula is ready to go. I can plug it in. Now, remember from lecture 1, we talked about PEMDAS. PEMDAS says we do parenthesis, exponents, multiplication, division, addition, and subtraction in that order. So what I'm going to do is I'm going to carry the formula down and work within my parentheses. All right. So we have 62.09 plus 109 minus 99.5 is what? 9.5 divided by 10 times 17.65. All right. So what do we have so far? We're working through our formula. We're still going to carry 62.09 across. 9.5 divided by 10. What's that? That's 0.95 times 17.65. Okay. Now this is at a point where I can't do the math in my head. So I'm going to go back to my handy dandy calculator and I'm going to do 0.95 times 17.65. And what am I going to get? I'm getting a number that looks like this, 16.767. So we're going to round that to 16.77. So we have 62.09 plus 16.77. Now I'm going to add that together and I'm going to have my final answer for the percentile rank. So I have 62.09 plus 16.77. When I do that, I get a number that looks like this, which is 78.86. So the answer is 78.86, or approximately the 79th percentile. And that, my friends, is how you do it. So I'm going to go back into the slides. Again, I'm going to remind you all of the steps. I'm going to say it one more time. Find your class interval, calculate HIL, H-I-L, find the lower real limit, and then you're ready to go and plug it into your formula. So let's go back into the slides and see how we did. All right, so I went over the process on the whiteboard, but now I'm just gonna archive it with the slides, right? So in step one, I said, find the class interval, which the score falls within. So the class interval was 100 to 109. Then calculate the higher intervals, the intervals for which the score falls, and then the lower intervals, and then calculate lower real limit. And then you could calculate the formula. So step one, we came to an understanding that the class interval was 100 to 109. We came to understand the percentages, right? 31 divided by 153 gave us 20.26. The frequency within that class interval was 27, so that divided by 153 was 17.65, and then 95 cases were below the class interval. Divide that by 153, you get 62.09%, and that's all there. So the numbers matched when I did it by hand and when I did it over here. And then I just plugged in the formula, and sure enough, the lower percent, we had 62.09 plus 109 minus 99.5 divided by 10 times 17.65. So that's going to give me 0.95 times 17.65, or 16.767, which is rounded up to 16.77. You add that to the previous 62.09, and then you get 78.8575, or approximately 79th percentile. So that is the first one. So that's great. So now you know how to calculate percentile rank. What if we did it the other way around? Let's say I wanted to know what raw score reflected the 25th percentile. If I were going to do that, I have a whole different procedure to calculate this. So let's go through the formula. Score P is the lowercase p is a percentile, so you do score 0.25 equals lower real limit. Now we still need to find the lower real limit of that range plus p times n, which is the specified percentile times the total number of cases minus the sum of the frequencies below divided by the frequencies within the class interval times the height. So I'm going to also write this formula on the board, and I'm going to work us through this formula. All right, so here we are at the chalkboard or whiteboard, and we're back, and the goal is to figure out how to calculate a raw score based on being given the percentile, right? And in this case, we're trying to figure out what raw score reflects the 25th percentile, right? So in this case, 25th percentile, right? So I wrote it over here, and now we have to figure out how to do it. So there are 4 steps. Step 1 is to identify the case that it would be the corresponding to the 25th percentile. Step 2 would be identifying the class interval that that case belongs to. Step 3 would be identifying the lower real limit of that class interval, and step 4 is calculating it. So let's see what we figure out. So step 1 was identifying the case, and we identify the case by taking the percentile that we're wanting to figure out in a decimal form and multiplying it by the total number of cases in the sample. So here we have P times N. So the percentile of interest is 0.25, and we're multiplying that by N, right? And the N is your total number of participants here, 153, or up here, 153. So we're going to write 153 there. So if I were to get out my calculator, what would the 25th percentile be, or what case would be the 25th percentile? I would do 0.25 times 153. And that gives me case number 38.25, right? So we're going to write 38.25, right? So that's step 1 is done. I wrote 0.25 times 153 equals 38.25. So step 2 is to identify the class interval the 38th case belongs to. Here's the trick. We work our way from the bottom of the cumulative frequency column up to where the 38th case might be. So if I work my way up, 1, 3, 9, 19, 36, 36 is the highest case. It has to be, 38 is after 36, but before 59, right? So it has to be, if my marker works, in that case, in that class interval. So the class interval of interest is going to be 70 to 79, right? So I wrote that in there. Now, the lower real limit, same rules apply. The lower real limit is 0.5 below the smallest number in the class, right? So I circled all the way around, 70 to 79, right? What's the smallest number in that class interval? 70. So I'm going to write 70 minus 0.5 is going to give me 69.5. Now I've calculated my lower real limit and I'm ready to do my formula. So let's do it. So score 0.25 equals lower real limit, which is 69.5, plus P times N, which was how we figured out the case. We already have that here, right? So it's going to be 38.25 minus SFB. SFB stands for the sum of the frequencies below. So if I go to the cumulative frequency column, what is the highest number below the class interval circled? 36, right? So I'm going to do 38.25 minus 36 divided by the frequency. Now here the frequency is the frequency within. So I go back into the class that's circled and 23 is within that F, right? So we do 23 times the height is 10 again, like it was in the previous one. So now I've plugged everything in to where I can start working through the formula. All right, so we have 69.5 plus 2.25, right? Because 38.25 minus 36 is 2.25 divided by 23 times 10. Now the marker's starting to work better, right? So I can't do in my head 2.25 divided by 23, so I'm going to use my calculator again. 2.25 divided by 23. That's going to give me a number that looks like this, 0.0978, right? So I'm going to carry that down, 69.5 plus 0.09, and I'm going to put 3 decimals here. 0.978 is going to be 0.98 times 10. Great. So now I can work this further. 69.5 plus 0.098 times 10. You just move the decimal point over 1, but I'm going to do it on the calculator just to be honest, right? So 0.098 times 10 gives me 0.98. It's just moving the 0 over. So 0.98 plus 69.5 gives me an answer of 70.48. So if I were trying to figure out what raw score would reflect the 25th percentile, it would be the raw score of 70.48, but that wasn't one of the scores. So we do or approximately 70, because in this case, we would round down. And that is how you calculate a raw score if a percentile is given. These are the only 2 formulas for today's lesson. So what I'm going to do is I'm going to finish up and I'm going to ask you to try some of the problems at home and see how you do. All right, so again, here we are back on the slideshow. I went over the formula, I went over the case, and again, we wanted to know what would the 25th percentile be. So step by step, we identify what the case number would be by calculating P times N. Then we identify which case or class interval it belongs to. Then we identify the lower real limit of that class interval, and then we calculate the formula. So if we do this, step one was p times n, 0.25 times 153. We got case number 38.25, which landed in the critical interval, a class interval of 70 to 79. And then we worked our way through sorry that the number got shifted over, but we had 2.25 divided by 23 times 10. And we got 69.5 plus 0.978, which we rounded to 0.98 in our calculations, which was approximately a score of 70.478 or 70.48 if we did 2 decimal points, which if we round to the whole number, we would say approximately 70. And that would be our answer. Now, there are other ways that are not as precise using the stem and leaf diagram. You could find the 120-second case, right? And calculate your answer. So if you did the first calculation and you went down the chart to number 122, you would get a percentile rank, right, of 79.73, which is not as precise as the calculation we did, right? It's close, but not as accurate. And then if you do the 25th percentile, we know it's the 38th case, and you could just count the numbers and find, and it would be a score of 70, right? So if we did this, added them all up, we would get to this 0 here, which would be 70, which we calculated 70.48 or approximately 70, right? So it works. It's not as good. And on the test, when I ask you to calculate percentile rank or percentile point, which is to calculate a raw score, you're going to use the formulas that I went over by hand, not these basic cases. Now, there are other terminology. Percentile, we already know that, that's times 100 or 100 parts. But I want you to think of the word and really conceptualize the root of the word. Percentile, what is the root of percentile? Cent, right? So you might have heard the term century is 100 years, or centennial, 100th year, or centimeter, hundredths of a meter. So percent would be taking any unit and dividing it into 100. Decile, think you probably know the root is deci. You've heard the word decade, right? A decade is 10 years. So a decile would be to break things into tenths. Quartile, the root of that is quart. You've heard of a quart of milk. You've heard of a quarter, right? So now you're dividing whatever it is into 4 parts. And then median is the middle point or midpoint, which is the 50th percentile. So these are all terms that you should know. And I'm going to stop there. I think this is a good place to stop in the lecture, and then we'll pick up next week.